Okay. Oh yeah, I've seen it. Let me just share the entire screen instead. Okay. I think you can hear me. Am I audible? Oh.
Yep.
Oh, okay. Awesome. So yes. So as it was stated during the week, as we were to learn about how we can call native functions and also how to create native memory. But maybe that looks like a general view about Java interfacing with the native world, but I wanted we start with describing what memory is, because once you understand memory, then you'll understand how functions are called natively and how to create memory natively, and how memory actually affects your application in terms of the capability it can do in terms of utilizing the hardware you're running your application with. And it all starts with memory. Memory is just the storage of data in your computer, but how it is described structurally is what many people don't usually have a grasp in terms of understanding the concept. And also Java tends to hide the information of how the layout is done. So most programmers in Java tend not to have that knowledge. And that's the case that happened to me. I started with Java, but later on I discovered that understanding memory layout is very important. Even other languages, even C, hides memory representation in terms of not giving the user information on how data is structured, but it has some specification of how it generates the layouts. So C is very good has a standard way of actually displaying layouts, and it's what C++ adopted. I don't know about C#, but most modern languages nowadays, they hide the layout because they want to have that freedom of rearranging how the layouts are represented in memory. And it's why most modern languages, you see the way to interface with them is through a C API. So C API nowadays has become the de facto of interfacing between different programming languages. And it's because it has well-defined memory layout. Okay, so we begin there. So here, as you see, it's memory representation and typed memory. And then down there is mapping product types to native memory. I believe you understand what product types are, but I'll explain further, but briefly. So we start with memory layout. I've actually presented this before, but it's good to have a reminder of what it is, and also I'll describe the rules. The rules can actually fit in one page, I think six lines, so that you understand the rules of memory alignment, memory layout. So memory layout, it's like a schema. So if you guys have done serialization, marshalling, you transmit data in binary form or through the wire, you tend to create a schema first. I think frameworks like GPRC, they tend to have a schema layout, and it's the same concept in a way. So difference between schema and layout. Layout is more like a shape. So shape is more like you say int. This field is based on int, and then float. But schema, they usually have added information like the name of those fields and maybe the validation for that layout itself. But that's a digression. So how pure data structures are organized in memory for system languages. So by the definition of system languages is quite difficult to say, because people usually talk about system languages, but there's no standard definition. But when you hear people talk about system languages, it's all about memory. So arrangement of fields is in contiguous memory. So it's like your keyboard, the way the keys are arranged. There's no space in between. So that's what we call contiguous memory. And then it's governed by alignment and padding rules. Alignment is based on hardware specification. Padding rules, I'll explain later what it is. And each field is placed at a properly aligned offset. If you notice clearly here, this statement means order. If you say, if your class has field X, Y, and Z, that's the order. But in memory, that's defined by the offset, where this Y starts, where this Z starts. But Java fields don't actually promise you that the fields will be aligned the way you define them when in syntax form. That's one of the reasons why records came, and then later on in future we'll have carrier classes. And then the padding itself is done automatically by the compiler, but Java Panama decided to make everything explicit. It's for the programmer to do that manually. So, and the reason is that they don't want to trap themselves in adding padding or providing a layout approach based on each operating system and hardware. So it's for the user to develop that framework. Actually, if you notice, since 2010, Java has tried to make everything explicit so that developers can develop libraries. Even the way the language is going forward, they'll give you the basics, and it's for you to develop a complex library on top of that. And Panama actually was designed that way. And then the overall structure depends on alignment requirements and actually alignment requirements. So this matters a lot. For example, performance and cache efficiency. Cache efficiency is everything. Actually, when people I've seen these fights on Twitter. So when people say Java memory model is the worst memory model out there, because what they are saying is that it doesn't have this cache efficiency, and I'll explain later what it is. And then native interoperability. As I said, if you notice Zig, Odin, even Jai, and then Rust, all those new languages, they use C for native interoperability, same as Java. And then serialization and memory mapping. Actually, my library is a form of serialization, if you think about it. And then memory mapping, and then systems and high performance programming. Yeah, so that's the case. So if you look at every language, just Google what their basic primitive types are. Every language has its own primitive types. Rust has a lot. Java has these main ones. Because you cannot they can never include all types of primitives in a language. So they usually provide the basic primitives so that you can build complex primitives on top of that. But Java, you cannot construct complex primitives on top of that. But soon that will change. But you need to understand their memory size. So, for example, a byte is digit 1 in terms of bytes. Char is 2 bytes, but in C is 1 byte. So if you are unaware of this, you'll encounter a lot of memory conflicts when you are mapping your code like a string to C string. So most C strings are usually represented as bytes in Java. And then short is 2 bytes, int is 4 bytes, float and 4 bytes. If you notice int and float, they usually have methods called to float or to int. It's because they're interchangeable in terms of memory representation. It's the same memory size. So you can apply rules to present a float in an int, and I think vice versa, as long as you have native memory access. But Java provides a way of doing bit manipulation so that you can be able to interchange. And then long and double, same concept. Beyond these values, these sizes, you now enter a different area called single instruction multiple data. That's usually more hardware specific. So that's usually out of scope for all programming languages. I think so. Yeah. If you want to go beyond that, you look for libraries providing such a kind of access. But in future, we'll be able to model this. I think so. And then Java soon will introduce vector API. Actually, they are waiting for value classes so that they can go beyond these primitive types that are target specific hardware. But you can also define your own primitive types. Also, the unique thing about primitive types is that they don't have an identity, which is very crucial. I'll explain later. So in C, this is a product type. So a product type has multiple fields. The reason why it's called product types is that if you count all the numbers that can be represented by maybe X, and then you multiply also by Y, by Z, you get all the possible values this struct can have. That's why it's a product type. And most languages are that way. And actually, the way you can prove that is maybe turn them to Boolean because it's 0, 1, 0, 1, 0, 1. You can actually see the different ways you can represent that data. And it has a formula, I think 2 power n. So for Boolean types, 2 power 3, that's, I think, 9 ways of presenting that data based on the Boolean types inside. But here it has, I think, billions, or I think so. I've forgotten the value. So in terms of how they are represented in memory, as you can see, these are offsets like 0. Let's imagine this is the point in a struct. So it starts with 0, X, and then since it's 4 bytes, you add 4 bytes. So the next one starts at index 4, and then 8, and then 12. So you can say the total size of this point is 12 bytes, and it's based on the size of each field based on the types. So the type is very important. This, but once you by now, I think everyone knows the size of each primitive. So it's usually offered, but it's important to know. So for this, it's just 12 bytes. So some people can see a struct and then they know these are 12 bytes or 24 bytes etc. But there's some situation where a language might introduce some sort of padding in between in terms of product type representation in memory. So, for example, you remember char in C is 1 byte. So if it starts at index 0, it's 1 byte, but it has to add 3 bytes so that it starts at 4, and then Y is 4 bytes, 8. You notice something? It's in the power of 2 actually. It's divisible by 4, or by the size of that field. For example, Y is size 4, so it has to start at index 4. And then Z is size 4, so it has to start at 8. So there's that rule you have to think about. But most programming languages, the compiler does that for you, so you don't have to think much about that. So so the right side explains the padding etc. So the alignment requirements depends on the language and also the hardware. In Rust, this information is not accessible. It's not currently a standard anywhere. So the compiler has the freedom to rearrange this, and I'll explain you why rearranging is important. And also the value classes in Java will take this approach too. So even complex paddings exist. So for example, this struct has char, C, that's 1 byte. Int is 2 integers inside, so because it's an array, so it's 2 ints inside. So they're well padded. There's no padding in arrays. I'll explain why there are no paddings inside an array. So for example, C starts at 0, so 1 byte, but since the next field is an int array, and the first each element size is 4 bytes, so it has to be a multiple of 4. And then since 4, okay, this is 4, and then 8 plus 4, 12. The next one is double, which is 8 bytes. Here it's index 12, but 12 is not divisible by 8, so it has to pad more. So it adds 4 bytes, so 16. So it's a multiple of 8, and then the total size is 24. So this is how C does its memory alignment in terms of product types or structs. So these are the rules, and I think there are seven rules actually. So each field is placed at the next offset, satisfying its alignment requirement. So alignment is usually a power of 2. And then the compiler inserts internal padding between fields when needed. And then there are some situations, for example, let's take this V is a double. The array is an int, so it is divisible by 444. So there will be no padding. And then after it, there is a char. So this is 8, and then plus 8 is 16. And then since the C is a char 1 byte, so it will be 17, but it adds 7 bytes. But the question is why? So in this fourth line, it says Kmax is equals to the largest alignment required by any field in the struct. So if you look at this struct, the largest single field is 8 bytes. So the last padding, the last offset should be divisible by the largest field size, which is a double. So it's an 8. So it will add 7 bytes, so that total is 24. So this is a multiple of 8. So with these rules, that's why arrays don't have any padding, because the struct inside obeys the alignment through offsets and padding. Therefore, you can never think about having padding in arrays, because arrays will never have paddings. So that's the principle. Before I understood this, it took me time, like almost 2 months. I didn't know the rules. I didn't know until I discovered a library on GitHub, and I was able to go through each line, and then I found a certain formula, and then that's how I discovered those kind of rules. And this one came from a Stanford University presentation, so I was able to use that. But it's so strange. There's no publication or a specification highlighting this, so it's quite strange. But once you understand that, things start making sense. So, for example, why order matters. So, for example, if struct S1, this one, actually this struct is the one we are going to use throughout this presentation, because I think it shows some bit of complexity, which is good once we start now thinking about Java. So struct S1 is the 3 fields. The first one is a char, and then the other one is an int, and then the other one is a char. So this is CID. So the first one is 1 byte, so it has to pad 3 bytes, and then I, which is 4 bytes, and then D, which is a char, is 1 byte, so it has to pad 3 bytes, total of 12 bytes. But notice the order reduces the size to 8 bytes if you start from the biggest to the smallest. That's why if you give the compiler freedom to rearrange the fields, it brings a lot of memory optimization. That's what Rust does. I don't know whether Zig does that, but value classes also in Java will do this. Yeah, so this is about memory optimization completely. So, but sometimes order has no benefit. Even if you start from the largest field to the smallest field, sometimes you don't gain anything. But it's good to be safe, on the safe side, always arranging the largest fields all the way to the smallest fields. So after this presentation and today's a meeting, just go to GitHub and look for C code anywhere, and you'll notice how people arrange their fields. You'll notice that order of fields. Some people don't really care, but for game developers, this is very important. For high performance computing, this is very important. And then notice something in Java, arrays are usually objects with identity, but in C, if you declare it this way, it has no identity. It is stack allocated. So it actually affects performance. And when I decided to do this in my library, I noticed some overhead, whereby my performance of my library wasn't in par compared with other languages. But I think Java, they are planning to introduce stack allocated arrays. They are called multi-field array, but it hasn't been made yet publicly, but it has been discussed on Reddit and I think in the mailing list. So once you have that, you don't think about array layouts. Arrays just, each struct is ordered very well. They don't have to think about padding, everything, etc. So let's enter Java Object Memory model. So there was a time I was making a user interface and I was dealing with Java beans, so I wanted to inspect them in terms of through reflection. And that's when I stumbled that issue that actually fields in classes are never ordered based on how you write them, because the reason is they are not even stated in the specification actually. So they are never declared anywhere in the specification. So different JVM implementation, they might obey the order or not, but it's not a guarantee. So the problem with Java object is that they have a pointer and then the pointer points to the actual data, and I'll explain why that brings an issue. So this memory model results to many cache misses, slowing reads and writes. Actually, this is, if you hear about Java is slow, this is the reason. This is what they're trying to fix. Even today on, let me share something. Even today on, this is the trending topic in Hacker News. Yeah, it has gone down. Yes, it's number 2 project. Someone gave a very detailed article. Look at those comments, 242. So this guy just gave the history of value classes in Java. So, but this is now people are encountering this new model, which if you go through the comments, some people are misinformed, some people are quite impressed, some people are quite confused. It's an interesting paradigm shift we are experiencing right now. But yeah, but the reason is they are trying to fix this line. The memory model results to many cache misses, slowing down the reads and writes. And I'll explain how that happens. So both languages, system languages, as they say, Rust, Go. I don't know whether Go is a system language. Zig, C#, which has structs. They were able to actually avoid the object model whereby a data has a reference, which slows down access to the actual data through reads and writes. So the reason is that in the beginning, in 1995, I think when Java came out, there was no issue of difference in performance between memory access and CPU instruction execution, but later on, CPU's architectures improved and they introduced redundancy memory hierarchies called cache slots. So so usually have the SSD, but do you know virtual threads? To switch from one virtual thread to the other, the first test they can do is, I think, 90 nanoseconds. And accessing data from SSD drive is around, I think, 100 microseconds. So when you hear that they haven't figured it out on how to do proper I/O in files, it's because the switching context between one virtual thread to the other during blocking while reading a file from the SSD drive, there's no performance difference. So that's why most I/O in Java using virtual threads, they block the carrier threads. Yeah, it's because of memory access actually. So SSD drive is 0.1 milliseconds. Main memory, the RAM, you say at my computer 64 gigabytes of RAM. So it's 62.9 nanoseconds. Now this is the most interesting part. So the L4 cache for 42.4, L3 cache 12.8, L2, L1, and then registers. Registers is a different beast of memory access. It's where the CPU will try to obtain data from this memory hierarchy and then store them in the register, and then now do the instruction execution. The most languages actually through assembly language. If you ever follow FFmpeg, they do assembly programming. If you look how they code, they usually go through straight to the registers. They don't deal with cache 1, L1, cache L2. That's why they usually say assembly. If any language ever beats assembly, that's a lie. Because it's a register access. But if you look carefully, I think, I don't know whether I have CPUs. Nice. I do. I still do. So as it opens, here. So I don't know whether it can display the cache size of my, here it is. So if you look at here, L1 data size, so there's L1, the cache is level 3, level 2, and then level 1. So each has its own memory size. Like a level 3 mine, it's 24 megabytes. Level 2 has lower megabytes, etc. If you can fit your data into this L3, L2, L1 cache, it means you have access to very fast memory access. That's why arrays are very common, or multi structs which have multiple fields. The way they align memory in their types, it's very important. So if, let's say, this struct can fit in this L1, the access becomes fast. But if you read an index in an array, the CPU will read that index and also the data surrounding the other indices, so that if you're going to call the next index, it won't go all the way to the SSD or main memory. It will just go to the L1 cache. That's why it makes things very fast for modern memory access in terms of accessing computation speed and also access of memory. So the idea is to flatten memory as much as possible so that they can fit in these slots. And the future value classes will take this advantage, whereby these fields will be dismantled completely and then stored in the registers. That's why Java never allows you to have access to the memory layout, so that it has that flexibility to do garbage collection. But now the new value classes, you'll be able to access Java will be able to access data, stored data in the registers instead of L3, L2, L4 cache. So it will be super fast. That's why I'm actually wondering how benchmarks in future will be comparing Java and Rust. So what happens when there's a cache miss? Because as I said, Java experiences a lot of cache miss. So the concept of cache miss is that the CPU requests data. For example, let's say in the beginning, when your program starts, you request data in a certain address. So when it reaches here, it will fetch a 64-byte line. It doesn't depend on the size of your data or each type. It will always collect 64 bytes of memory, so that if, let's say, it's an int, and an int has 4 bytes, so it means this is how many? I think, is it 18 or whatever? It will read many indices in that array and store them in the cache. So once you request data, a whole bunch of data will be stored in the cache. And then if it requests again the next index, it will look first in the cache and say, wait a minute, the data is already, the next data in the maybe index 1 after reading 0, it's already in the cache. So it will process first and then return. That we call a cache miss, a cache hit. But if it reads index 1 after reading index 0, it becomes a cache miss, and then it has to go back to the RAM. So, and then now go back to cache and then go back to CPU. You see that latency of reading data from the main memory. So that's the issue. So that's unfortunately that's how the Java memory model is because in an array, as I had mentioned previously, in C they store the actual data, but in Java, if you store objects in an array, they don't store actual data in the array. They just store references to that data in the array. So when the CPU reads the data from maybe index 0, it actually reads notices, oh, this is a pointer pointing to a data in a different memory area. So it will it will read a whole bunch of reference first, and then it might even read maybe depending on how the data is stored, it might actually store some data in the cache actually here. And then if it reads the reference, and then it will know, oh, the reference points to the actual data somewhere. And if it's in the cache, that's it's supposed to be a cache hit here. If it finds it, that's good. But since it's not the actual data, it will always point to a different location. We encounter a lot of cache miss. So that's why many years have gone where CPUs have improved memory access, but Java hasn't adapted to that memory access architecture of modern CPUs. And the reason, and that time, people usually say Java does a lot of pointer chasing, so it has to go so many corners before it gets actual data. So that's the reason. And if you look at there is poor spatial locality that is not well grouped for me to search around the memory neighborhood for the actual data. So it has poor spatial locality in memory. So which increases cache miss probability. And then this leads to high memory access latency. So, sorry. So yeah, so at least now you understand the reason of why memory layouts are important. But as Java developers, we don't have this kind of information. We tend to trust the JVM to do much of the work for us and to optimize as much area as possible. But unfortunately, optimization has limits. So the best way to tackle that problem is to remove references and store the actual data contiguously in memory. And arrays are the best way of storing the information contiguously in memory. So having C arrays in C, they're quite efficient because of that. And Valhalla also wants to deal with that access. So for here, if you want to read, it reads this whole 64 bytes all at once and stores them in the cache. So if I read 0, yes, it's in the cache. If I read index 1, it's already in the cache. If I do that, that's the beauty of cache. So when you're buying CPU, always think about your cache memory, and you can check in your computer. Download CPU-Z, it's free online. It gives you access to your hardware specification. So in future, Java will do the flattening. So instead of pointers, the headers, every object has a header and then the data itself. In an array, it's the header and then references to those headers. So reference. I think reference is 32 bytes. 32 bit, sorry. 32 bit, the reason is because in 1995, most CPU architecture was 32-bit, and it has never changed, actually. So references, you can use, actually, what do you call it? You can use the GTorch, I think, and what else? There are some tools you can use actually to check how memory layout is done in Java. So this is a lot of pointer chasing. That's why you'll see this kind of diagram when you read about memory in Java. So now you understand the concept why. So in future they are going to remove these headers. So in an array, it will be short. So it will be the same based on how it's going to be arranged contiguously, and then this will enhance a lot of cache locality, reducing cache misses. And notice something here. This is a Java array, but if you zoom carefully, there's a null restricted type. I'll explain why. Yeah, that's a giveaway or something you'll see. So the reason why is that the current Java value classes, they will have null marker. So you might think it's short X, short Y, short Z. No, it will also have a null marker. So some people are testing value classes in Java and then they discover it's not fast. It's because beyond 64-bit, it becomes a Java object, an ordinary Java object with pointer chasing. So in future, once we have null restricted types, this null marker will be removed, and then there'll be header, short X, short Y. Right now, this is how Java arranges memory with value classes. Most people will notice there'll be no speed, but the reason why they're introducing value classes is because they now have a way of now removing identity. After I think Java 28, that's when they'll start now doing proper optimization of Java, and then JEP, like I think JEP 4.2 or what, they'll introduce null restricted types. So once they introduce null restricted types, these null markers will be removed, and then also the 64-bit whatever. So at least now you understand memory layout. Actually, what I've described, I hope rewires the way you think about memory handling in other language. You have to think about, do they flatten their memory? Do they introduce value structs or value types, value objects, like in Odin, in C, even C#. C# has both. It has structs and also ordinary class objects. So, but the approach was quite interesting with some traps, which they tried to resolve later. But now you have an idea. If you now go research other programming languages, go with that mentality of how is memory laid out for a given type, which has multiple fields. Always have that idea, and how is it represented in an array? Then you'll understand why it's very important. So, and the beauty about that is that you can predict memory size, actually. Yeah, so if I have an array that has 1,000 elements, it's possible actually to calculate the memory size of that array, so that you understand this system hardware I have. What strategy should I take? For example, when you're programming your phone, you're programming your watch, etc. Memory is very crucial to such systems. That's why it's very hard to find Java being used for system languages as a system language. Yeah, so that's the idea. So I wanted to introduce something else: method handle and var handle. But then after this, actually I would have explained what Panama is actually, because you have to understand about memory layout and then method handle and var handle. By the way, this is the reflection too. It's a way of doing reflection safely and fast in Java. The old approach of doing reflection is outdated and it has security issues. So this is the new strategy of doing method handles and doing reflection in Java. And it's a bit unique. So what are these method handles and what are they? Method handles and var handle. For now on, I'll be using the term mainly method handle. because var handle somehow it's a subset of method handle, so it's the same concept, but the idea is through the name. So you access methods using method handle, and you access fields of classes through var handle, or whichever. So that's the idea. That's the mental image you have to have. So method handle and var handle provides the JVM access to Java methods and fields, and also support native function calls and native memory access through the foreign function and memory API. So now you see the reason why I needed to introduce method handle, var handle before we enter Panama, because method handle, you can access methods in Java classes, including static, private, fields, method instances, etc. And then also in C, functions are usually accessible through pointers or symbols, depending if you program languages, to design languages, people tend to use symbols instead of function, terminology instead of function pointers, but they're a bit the same. But var handle, when you need to access fields in a class, you use var handle, and then instruct like in native memory. It's good to access native memory using var handle. So that's the idea. So before we start dealing with method handles, you have to describe the shape of your method. Remember, a method has parameters or no parameters and a return type. So when we program, we say string and then greet the method name and then the arguments for that method. That's the signature of the method. So there's a class called method type. I think I can access. So it's a method type. I hope my internet is fast. Okay, it's fast. So method type, it's a way of actually describing how to describe the signature of your method signature, and usually start with the return type, and then the parameter 0, and then the rest of the parameters, etc. So that's how you define a method signature. So for this one, string greet, you start with string name, integer. So you look at only the type. So you start with the return type, which is a string, and then there is a string name, which is the string.class, and then int.class. So that's how you describe a method type. And you'll encounter this. It's very rare to encounter this approach when you're programming generally in Java, but it's very crucial when you're going to different models of programming that is not usually idiomatic in Java, which I'll explain later. And then based on that, if let's say this is a method in a class, now you can find a way now to access the method. I think we can try to do that. For example, okay, let's start with now the method. So let's start with public string greet. Then you say string name, int age. Here, I need to zoom in.
Oh yes, in fact, that's what I wanted to ask.
Oh yeah, I understood. Yeah, so let's say hello, and then plus name, plus age, plus age, that way. So we have that method. So we start with void main, then you save, and then it automatically detects this is the main method and throws throwable. So we initiate the method handle first. Yeah, so you need, this lookup is to identify where this, sorry, supposed to be that way. This lookup is to identify where this method handle is being called from. For example, it detects automatically it's being called under method handle test. So it's for security purpose, because in future, if you enter in the world of modules, there's prevention of accessibility to certain modules through restrictions, etc. So it's good to detect that as early as possible. So we initiate it. Oh, sorry. So this is supposed to be capital. And then we develop the method handle to access the grid here. So method handle grid handle is equals to lookup. Now lookup will try to find it has methods to look for to find specific methods, I think even variables, etc. But here we want to look for the method grid. So I know it's find virtual. It's because Java methods are not stored in classes when it's running. They're stored in a table called lookup table. It's called a virtual table. So it's usually called V table. So we say it's a method handle test that class, and then the method name is greet, and then we enter. Sorry, let me put a semicolon and then enter, because here the method type is long. Oh, it's not been detected. Let me add the, yeah, so the import. So method, so it becomes method type, because now we are defining the method type, because we don't know the method signature. So it's method type. So which one was it? Oh yeah, the last one. So the return type is string that class, and then the arguments are string that class and int that class. So yeah, that's it. And then here we say person is equals to new person. Now this, sorry, let's say method. Then method handle tests. Hope it's going to work. So is it possible to call this method without explicitly calling it? We'll see. So you can say, let's say string result is equals to string, and then greet handle, and then we call invoke exact. Yeah, so we invoke exact, which is the person, the instance itself. Then we say, because now we are invoking this method greet handle, so we say maybe Ian, and then maybe he's 38 or 48. He's an old guy. Yeah, so, and then from that we can print the results. Notice we haven't called the method the way we usually call a method. So let's see, let's run it. Of course, Marvin will produce a lot of noise, but let's see whether it will bring any issues. Yeah, it is. Oh, of course. It is hello Ian. So maybe the spacing wasn't good. Oh yeah. Yeah, the spacing wasn't good. So let's try that again. Yeah, hello Ian, age 48, or also here. Yeah, so hello Ian, age 48. Notice we haven't done the usual process of calling this directly. We used a method handle. So that's how we do it. And you can, there are so many, if you go to the Java doc, so this is, yeah, method handle. So if you look at the method handle, I hope it loads quickly. Yeah, so we can, by the way, it has a very good introduction content, so you can go through it later directly. But sorry, I'm supposed to go to the method handles lookup. Sorry, I think this is the lookup. Yeah, I think the first one. Let's see whether it's that one that has. Oh yeah, as you saw up here, when we initiated the lookup, we looked for the instance method using the word find virtual. So it has very many methods to look up specific classes with whether it's a static method, whether it's an instance method, special. Find special is interface methods. When I was developing my library, there was a time I was wondering how come it's always throwing errors when I generate bytecode, but when I say invoke virtual, it brings problems. It's because I discovered this one is specifically for interfaces. So find special and then find static, find virtual. And that's how you can access methods. And based on that, now you understand what you need. You need the method name, the method type signature, and then the lookup access. And if you look at my library, I don't know whether it was stated explicitly. The README, let me confirm. No, it's not. Oh, but these examples might mislead you, but you need to have a lookup here when you're dealing with anonymous unnamed classes, because unnamed classes don't have a default class name, so it will always launch an error until you go to the until you launch a default lookup. If you go to the source code and then main Java API memory, mem. There's a method off. Is the off? The off should be down here. No, not there. I hate Java docs. Oh yeah. So I hope I can zoom in. Yeah. So you notice I provided this name because this parameter called lookup because of security concerns. In case you are launching this, you are testing this using source files directly. So the lookup is very important but in some cases you don't need it. If you look inside how I've implemented the lookup down here, sometimes it uses the default one. Yeah, when so this one is launched automatically, but when in certain cases this doesn't work, so you have to do it explicitly. But that's a digression a bit. But lookup is access permission, and then you have to have method type. I think now you have a clear understanding. So find virtual. Instance method, find static methods. Oh yeah, find special is for special instance calls, so direct special calls such as super. Those are interfaces apparently and abstract classes, or the classes, the super classes whereby the class is extending a different class, and then private methods. This one might bring a lot of issues if the app launches with a security that requires security permission, and also find constructor. But the constructors are methods, but they're not really regarded as actual methods. Constructors don't behave like normal methods, but they're usually grouped in same category as methods. But that's the answers. But you can go and practice. You can go and test using various classes just to play around. You see, my code is very simple, so you can go and actually learn, do some experiments out of curiosity. Oh yeah, so this is what I was saying. So for example, this is the class. You see the class main. It has, you call it explicitly. Here you give it the main.class as I had shown, but notice when it's the unnamed classes, you have to call it lookup.lookup class. So this is very important when you're calling find static or somewhere else where the method you're calling in, it's in an unnamed class. So this is just a security issue, nothing much to think about. Yeah. So yes. So hopefully you guys are understanding. Is everyone with me? Or I hope everyone is understanding what I'm explaining. So is there a question? Sorry. Yes.
Is it possible to use that method handle to do unit tests for private functions? If I have a private function, can it help that?
Yes, but it depends whether there are security permissions that are required, or
if I don't have any security permissions, it's just a simple Java project.
Yes, that's fine. It's okay. Yeah, you can test it. Yeah.
Nice.
Continue.
Oh, so it's not limited to the package or the module in which that function exists. I can because the unit test will be like on a separate package and a different location of the code, and I can still look up the functions that are in the actual code.
Yeah, because you see, here in this code, you start with method handles that lookup. So it now knows which class it's this lookup is being called from, which is main. And if it has this information, it knows which package or the details of this class. So when you say main.class, it will use this the imports up here to identify which this class is in which package, and now access the method. So it deals with packaging automatically. Yeah. Okay, no problem. So that's the basic way of doing method handles, but there's something interesting about this. Method handles and var handles, they are quite intriguing because they are not normal Java methods. That's the shocking part. They are treated differently. The reason is, if you look at here, what do you call? If you look at the bytecode generated, for example, but I don't know whether this will be a complex explanation, but I'll try. So, if you look at the bytecode of, let's try an example of. I hope this is the correct one. Nope. Is it the method handle test? No. Yeah, this one. So let's start here. So this is a main class. It has a record point, and then there's a static void string, static void dbl, static void point. So I try to access the methods through the method handles. So just the way I've explained. But let's remove everything here first. Then we save. Now we have left with only static void string, etc. Oh, continue. Who's asking? Someone is asking something. Oh yeah. Yes. So if you look at, let me see whether I can access the code. I'm sorry, this feature has no zoom capability. Oh, maybe I could launch it through NetBeans first, and then you'll see. The one I'm trying to, I added zoom capability for the bytecode so that you don't strain yourself. I'll use this instead. Yeah. So, I'll try to show simple code as possible, so bytecode as possible, so that you don't get lost. So let's enter here. Target class com and var handle. I think this is handles. Yeah, I think we in the correct package. Then we open. So this is main. Okay, yeah. So let me zoom in. Let me first maximize, and then we zoom in. Control. Yeah. So okay. Let me call these methods here first. Let me return this, and then control star to hide this method handles first. Let me hide them first. I'll remove them later. And then let's call these methods. I can borrow this actually. Then paste them here. Control V. Then I say int string. That's and then DBL. And then point. So if you look at the bytecode, I hope, I haven't saved it, that's why. Yeah, it has updated. So where is it? So if you look carefully down here, sorry, tupa into this complex thing. Yeah. So if you look carefully here, this is the method call. Is it the correct one, or am I? I think this is the correct one. The one that is. Let me confirm something. So it's not supposed to show this. Let me check this. The correct package. Simple concept com. And this one is. Oh yeah, it's correct. Okay, let me remove this first. Don't know why. Okay. Then, sorry. Oh yeah, it was taking me to the wrong. Whatever. Okay, let me zoom in. So look carefully here. I think this is the best I can do. So if you look at the invoke static, this means I'm calling the methods up here, DBL here. So notice the signature is sort of similar to in string. The method signature is similar to here. So there's void, it returns void, and then the method signature int string. And then if you go down here, it's DBL double etc. Notice it's actually calling these methods directly, and it's shown here in the bytecode. But here comes now a very interesting thing, which I was almost shocked. So if you go back to the original code and then say Control Z, Control Z, Control Z, Control Z, Control Z, and then remove all this. We are calling now the lookup etc. You might expect to find method handles etc in the bytecode, but if you go straight to the bytecode, did I save? Nope. And then I go back to, it usually jumps. If you go back to the bytecode, it actually, something is wrong. Oh yes, you'll notice here, it will call the method handles, but this invoke exact, it will, when it's calling these methods invoke exact, you might think the method inside it has these actual method signatures up here. invoke exact int string, invoke exact double. Now we are invoking these methods based on the signature itself. But if you go to the Java doc, sorry, where's the Java doc? If you go straight to the Java doc, invoke exact, I hope it will take me there. Yeah, if you look at the Java docs, this method signature is different. It's, oh, sorry, reset. Look at this. Invoke exact is object args, but if you look at the bytecode, there's no object array here inside the call. It's exact method type signature int string, which is similar to the method. It's as if this method invoke exact int string is inside the method handle instead of having this instead of having invoke exact object args. This was a bit shocking, and I was wondering how come, until I discovered method handles and var handles are the only classes that are part of the Java specification. Here, where is it? It's usually stated polymorphic here. Yeah, they are the only methods that are unique to Java language, and they have a term called where is it hiding? Sorry. Yeah, a method signature polymorphic. If it's a signature that morphs its representation in the bytecode based on the method type description. So remember, I was saying if you want to describe how memory is defined, you use this method type. It takes information there and then transforms the bytecode to actual method invocation. It means it removes these casts. If you look at the original code here, it removes any casting that might be involved. For example, here in method, if we looked at the bytecode here, all these casts are removed because this invoke exact in bytecode is transformed to the actual method arguments with the exact type. So there's no, because casting is very expensive and slow in Java, so they were able to enhance this. So it was a bit shocker to me, and the reason why they introduced this is because they wanted faster reflection and also a way to invoke native function. Sorry, nimeweka hapa sana. So, but yeah, that's the idea. So if we go to the next slide, so this is what I had presented. So this is how it looks in the method argument. But once you call an object or a method using the exact type, it's replaced differently into the exact method type in the bytes. So this one object becomes my class, 1, 2, 3 becomes an int, so that there's no object allocation, there's no boxing, there's no object return, there's no check cast or unboxing. These things tend to slow down Java performance. So var handle is the same with method handle, but now you reference you reference now the fields, for example. So it's the same the way we did, and then lookup will find var handle for this class, and then the field type age, and then the type int class. And then from there, now you can say age that set pass on this instance, and then add 30. And then if you get and then you can do get, and then that's how it is. And it's very performant. It's like calling a regular method. So there's no performance implication, which results to people might abuse it in a way, but that's the essence. So go Google what signature polymorphism is. It's a concept, but it has never been indicated in any publication. To many Java users, if you are doing very detailed Java programming whereby you need a reflection, etc., you'll encounter this concept a lot. Yeah. So this is what I was supposed to show you, which I showed you actually in the bytecode definitions, etc. So, but I noticed a certain pattern in Java. Everything has a schema or a shape. So method handles has a way of describing how methods are supposed to be, like method type, which is a signature. A field can be described using coordinates. Var handles have the field and then immeasurable number of arguments. Actually, the total is 256. And then foreign function, they have their own method type. You cannot use this same method type to call native methods. You have to give function description, which is similar to method type, but you use method handle. Even accessing native memory, you use memory segment, but you have to describe the memory layout. But to access that memory layout data, you use a var handle. And then this wasn't supposed to be here, but this is just proof of concept that everything in Java, you can describe it with extra information. That's why I say everything in Java has a schema. Yeah. So that's the mental model I want you to have. And then another thing called atomicity before we enter Panama. I think time is running out. So in certain situations, there are data races. I believe most programmers here, you understand what data races is. For example, there's a variable whereby we want to, which has initial value of 17, and then you increment it to 1, which is equals to 18. So let's say there are two threads accessing that variable. So thread 1 reads 17, and then thread 2 reads the same data from that place, 17. Because threads are not synchronous, they are not concurrent. They don't. They're not executed. I mean, sequentially. One thread might write, and then the other one writes at the same time. So instead of saying 17 plus 1 is equals to 18, and then 18 plus 1 is equals to 19, they might overwrite the same information so that it's 17 plus 1 is equals to 18. So the two threads return the results. When you read, it's 18, 18. This is conflict of information because of threads reading and accessing the same memory region. So many languages have a way of dealing with that. There's usually synchronized. People doing backend, I know you understand what this is. And then there's atomic integers. When you need to increment an integer, this problem can be solved by atomic integer, atomic long. Even var handles has atomic operations. And then one thing is to deal with immutable objects. That's why Rust has immutable types by default. Var handle, even you can check the API. It has, I think, atomic calls somewhere. So let's see, var handle. If I'm not wrong, I haven't used it for any atomic. I think if I do atomic, oh yeah, if I search methods that do that, inside here, yeah, compare and exchange. All these are atomic ways of doing incrementals, changing fields of specific memory regions or classes, etc. So these are atomic gets and sets. So, and then immutable objects. So data races are very common in languages. So how have they solved it? So, for example, in Java, we never experience certain conflicts when we are reading. Maybe okay, for example, data corruption might happen, but Java takes advantage. If you introduce synchronization or atomic integer, they usually use the header information in every Java object to make sure this data access here is atomic access. So you can, when many threads try to read and write, it has to be done sequentially. So that's why references, Java, we have objects are actually references. They have identity. It's because they have a pointer, and that locks the accessibility to the data inside that object. So we never experience these issues. So synchronization tends to be very safe. Atomic integer and atomic long tends to be very safe in Java, etc. So, but unfortunately, if we remove identity pointer like value classes or structs in C, there's no way of preventing it. Tearing has to happen. So old value, XYZ, and then new value, maybe you might overwrite one area instead of overwriting everything. So you might plan to write everything here, but only one side is updated. So that's what an issue of tiering. And processors, modern processors have a way of atomic reads and writes, and computers tend to be 64 bits. So 64 bits atomicity means that if your data size doesn't not go beyond 64 bits, you're safe. Now you understand why you need to understand about memory layout and size. That's the reason. So, but for example, this value classes is this is 32-bit, 32-bit, 32-bit. This is 96 bits in total. Even if you do synchronization on anything, you will not prevent tiering because the CPU architecture cannot prevent that beyond 64 bits. That's the problem. But below equal to 64 bits and below, everything is fine. So if you do atomic reads, writes, everything is safe. And don't think it's a Java issue. Every language has an issue. And the reason is if you create a class that is only unsigned point, meaning everything is greater than equal or greater than 0, if memory is corrupted through tiering and through tiering or access of reads and writes to that memory, you might have a negative value for these fields X, Y, or Z, and therefore skipping this validation. So that's the problem. Every language has this way of describing validation. Even C#. C# is this was a meme showing how complex it is to write a value class in C#, but it's the same thing. And once it skips this validation test, your software starts behaving badly, and then you start doing endless debugging. That's a fear for any programmer. Even I've been in Twitter, and I usually hear people saying we need to do reference allocations in Rust, etc. It's because of this fear. And different languages have different approach. Oh, ask. Someone is asking something.
Yeah, I was just wondering with the example you showed with C#, why are they using that read-only keyword for a class declaration?
The biggest mistake they did was to make structs mutable.
Oh, okay.
That was it. So, for example,
so it's like pass by reference, but on a struct.
Yes. That's why the fear is in C#, you cannot differentiate between a struct and a class when it's an instance. It's being passed by as an instance. So if the struct is mutated somewhere, and then you pass it as a method, instance method by value, it will be copied.
Oh Lord.
That's the unfortunate thing. It's something they regretted later. Yeah. That's why they introduced read-only later. Yeah.
Maybe they were trying to make it such that in C# the struct will not be too different from the class, but it's good to separate them. Like languages like Swift, where they are completely separated, it's good design, and this just leads to confusion.
Yeah. So that's why other languages wait for another language to see how it progresses, and then they discover, well, this is a mistake. So, and even there are blogs, articles about it. I can share them later on. So yeah, that's the idea. And actually, now if someone asks you why value classes are immutable by default, now you have an answer. Yeah. So C++, they don't have a way of avoiding tiering to trust the programmer. So that's why there are so many bugs. Go to FmpEg repository or just check on their issues. It's memory issues. That's the problem. Yeah. So this is a worst nightmare for every programmer. But you'll never hear a Java programmer complaining because we are dealing with identity references. So we are usually safe when you are using synchronize or atomic integer, atomic object, etc. Rust has borrow checker and ownership. So if you are done with a field and then you use it in another operation, the previous field that copied it becomes redundant. So there is that ownership model. So one thread at a time, that's the idea of Rust. And people complain about ownership and the borrow checker. So just Google how to disable borrow checker. You'll see so many articles. Yeah. It actually stifles your programming knowledge, your programming flexibility. I mean, Java objects, we use reference in direction. Valhalla, they will make it atomic by default. Once you go beyond 64-bit, it returns to reference in direction. The value type, value class, value object changes to the old plain Java object to make sure tearing doesn't happen. But it will let users be able to relax that rule. So that's why when people are excited, value classes are coming soon, they won't see any performance difference. There was a Twitter, I'll post that in the group, someone complaining, hey, I changed everything to value classes using the Valhalla JDK prototype. There was no difference in performance. But if you go straight to the value classes, you'll notice the memory size of the value classes exceeds 64-bit. Now you see the importance of understanding memory layout. And then there's Swift, actors and exclusivity rules. Maybe some you can explain later what that is. And then Z-coding, leave everything to the programmer. J is not commercial. It's not available. You request the designer, language designer. He released a game with it. He's about to become rich. As Odin is good for games, so it's idiomatically the syntax is so good, and it's the best language to interpolate with C and C++. Zig is the one trying to compete with Rust. The wars between these two languages is big. But my Twitter feed is full of fightings between these two classes of programmers. Yeah, so now you understand how other languages, you see, once you understand those basic concepts, you start now investigating how do these other languages solve these issues. Yes.
Yeah.
Someone is asking?
Yes. Yes, I was just wondering, what is the difference between Zig and Rust in terms of memory model? Does Zig also implement a borrow checker, their own ownership style, or
no,
it's different?
No, it has no those kind of strict rules for accessing struct fields or writing to them. Yeah, so it's, for example, ask a Rust programmer to construct trees whereby the object itself references itself. It's impossible to do with Rust because of this borrow checker ownership. Zig doesn't provide all those things, so it gives a lot of flexibility to the programmer. But one thing, beauty about Zig, it's type safe, very type safe. There are some type safety enhancement it has that actually better than Rust. Actually, I could say Zig is better. It's more safer than Rust, to be honest. And they have better async await library. The Rust talk is really bad, actually. Zig, Zig tried to remove the color function as much as possible. Yeah, so, and then Zig is very fast in compiling, actually milliseconds for large programs. So that's why, and Rust can take even 5 minutes to compile. So those are the language wars they tend to have. I might want to learn about Zig also, so I haven't done. Even Odin, so many languages to learn. Yeah, that's why I was very interested to know about NeoVim that time in the group chat. It was because of this. I want to learn about these languages for fun, just for fun. So when people complain value classes don't have those atomicity, etc. Things, someone pointed this to me in Java Reddit before it was removed there. There's this internal annotation, loosely consistent values. So this is beyond 64-bit, so it will automatically become a Java object. So you can remove that rule through annotation, but this has to require special access. So in future, this might be a keyword. So it might be non-atomic, and then value record etc. And then a flat array, because when I stated arrays have null markers, this annotation, even if you look at the name, new null restricted non-atomic array, you see it, even by reading it, it makes sense. And then there is flat fields. Fields have null markers, so there's internal VM strict. Strict means fields should never be null. You have to initialize them in value classes, so they have to have default values. And then they are null restricted that way. So if they include everything like this, they will be able to be performant like Rust. And someone actually developed a library to test all these features. Let me poleni naweka sana, but I'm just showing you something. Stars actually, yeah. So there's this lady, Liduma, developed this library. I saw her commenting in Reddit, and Brian said, continue with this type of test so that if you find any issue, just tell us. And if you go inside and then check the classes, let's say matrix. Let's go. Let's see maybe matrix 3. Let's go inside. No, that's really bad. Is it matrix 4? Where did I see this? No. Let me go to. Is it here? Where's the implement? Oh, I think it's the tests. I think it's the tests. Yes, the test. Let me go here. Where did I see? There's a way he has been able to. Oh yes. Oh yeah. Okay, it's the naming. Actually, I should have gone with the naming. You see, she was actually eliminating null types in this. And then in her Reddit comment, she said she hasn't seen any garbage collection, and she put all this, so she could create even gigabytes of data information, and there's no garbage collection, and it was outperforming Rust actually. So that's the beauty of removing identity in Java, and that's where they're heading. So yeah, so that's a segue. Just know that. Same knowledge. So when value classes come and you don't find them fast, just know that they haven't made this yet publicly available to us. So, yes. So I wanted to show you, because now you understand about how. Sorry, continue. Someone is asking something.
Yeah, sorry to interrupt you again. Using that annotation, a null restricted type.
Yes.
Does it mean you'll get compile time checking if there's
yes.
Yeah, because that's really interesting. Can you elaborate a bit more on that annotation?
Oh, there's a JEP for that. Let me show you. Yes. So, but people are not aware. Actually, if you go to Hacker News, people are saying they don't have nullability. What is this? I don't know what. Blah blah blah. Even someone said, even this one guy here, this won't be true in Java, though Java will have null integer at least. It seems that int will remain a different thing entirely from integer. And then I correct the guy and say, but with null restricted types integer, and then null and null restricted and int, there will be no difference, both semantically and representation. Representation means in memory, and they plan to do that. That's why someone, I don't know who, liked my comment. Yeah, so there's a fight ongoing here because of people understanding that JDK 28 will have preview of value classes. Hey, there's a lot of work. Actually, right now, it's how many comments? 242, and it's rising too. So, just now, even I've searched for it many times, so it will take me there directly. So, here is the JEP. It's still in draft. It was updated last year, and it has these 3 markers. Oh, so the usual Java instances where you say without this, string, without this, and then name. it's called it's just a nullness. Let me talk about this too. Yeah, so there's null restricted, whereby there's no nulls at all, and then there's the nullable, the value set deliberately, so it can be null or non-null. But this one has to have values, and then there will be the normal nullness, whereby it's unspecified. Oh yeah, this is the word I was looking. The current Java, we know it's unspecified. And then there's this nullable. So there was a time I was confused if this type can be null or non-null. So what's the difference between unspecified and this? The difference is that this one will assist the compiler to do some analysis, and this one will be enforced during runtime, the question you are asking. This is a very interesting JEP. And then, I don't know whether, and then there will be, I've been talking about this in the WhatsApp group, whereby we shall do widening nullness conversions, and then narrowing conversion. So it means VS Code, let me use VS Code, it's easier to write here. I don't know whether I can zoom in. Let me create a new one, file new. I don't know whether it will ask me. Put jo.text, then put it in the documents, maybe here, then create. So can I zoom in? No, I cannot zoom in. Oh, okay. Don't show. Oh, now it's accepted. Okay. Oh, how do you zoom in? Forgot it. Oh, maybe it's Control++. Oh yeah. It's a browser. So let's say point P. Okay, let's say this is a method point get int I. Let's say it's int I, and then this is a method that. So this is what you program nowadays, but how do you ensure in future there'll be backward compatibility? So they want to introduce this concept of widening nullness and narrowing nullness. So it means in future we can define somewhere point and then say this, and then P is equals to get maybe index 5, let's say 5. And then the JVM will check whether the value exists, and then if it exists, then this is automatically compiles. But for Kotlin, you have to do something like casting, sort of. By the, I think, by the kuna time I argued with someone, that's why pattern matching, all those things, it's a concept of widening and narrowing types. So for example, if you have an object, if you look at the way pattern matching is, you say instance of point and then variable X, you're narrowing the type to a specific type. This is narrowing. So the point is a wide type, and then you narrow it directly to a null restricted type. This is allowed because the JVM analyzed this method, and so it exists, and then it does that. So here, this P can never be null. This will be a compile error, or that way, etc. So those are the benefits you are going to have through widening conversions and narrowing conversion. That's why there was a time I asked Brian about it on, I hope I can remember where it is. I think I can show you my conversation with him. Tunaweza extend kidogo, it's okay with you guys. Oh, 2-hour session. Oh, so I skip. Let me skip. Okay, naongea sana. Okay, sawa. So okay, so yeah. Oh, okay. Sawa. So okay, that makes sense anyway. So I think I can go scroll down a bit. I hope my name. Oh yeah, here it is. So here I discovered something interesting, and they haven't pointed it anywhere. But I discovered a consistency rule that everything in Java is going to be about narrowing and widening types. So for example, let me surprise you with something interesting. So let's say we have an interface, maybe foo extends permits. Okay, so let's say this is sealed, and then implements. What do you call it? Oh, permits. Maybe foo implement 1, foo implement 2. Let's say there's something like that. And then somewhere in your code, you write, let's say, foo f. This is now the interface is equals to. Let's do a switch. Maybe it's a variable v, and then we say since this is an expression, it has to have a comma, and then we say case foo implement return maybe if foo case foo implement 1 return v, maybe I think there's a cast or something, and then same thing here, foo implement 2 do something blah blah blah, and then it returns. But in Java currently they will force you sorry. So it's supposed to be foo implement maybe 1. So if it returns this, here you throw exception. I won't write everything because we want only foo implement. If you write this way, Java will force you to cast. And that makes sense because the compiler knows that foo has 2 permitted classes, 1 and 2. But what if we remove this one? And then we remove this one. The compiler still will force you. But they discovered it will force you to cast. But they discovered later on, if the compiler can know it's only a single permitted class, then, let's say, sorry, it should be a method here, get something. And then, return something. If it's supposed to cast, then why not one day, instead of doing this, we can do this. This one is exactly the same as this. And this is what we call narrowing. And it's actually in this JEP, which is going to come out this year. Locally enhanced variable declarations. So that's the exciting part of this JEP. It's hidden in the description inside here. Actually, someone noted it and I was a bit surprised. So a single permitted interface, it's similar. So this one will be doing type checking in advance. And so I noticed that consistency. So here I asked, for example, okay, I'm trying to understand this narrowing assignment context. So it means this assignment context. For example, the sealed types with a single permitted implementation, there will be no casting. And then I discovered later that null restricted types, if the get point is it's nullable type or it is unspecified, if the JVM can prove it, then this one works, unless it throws an exception during runtime. Then I wondered, how come I haven't seen this with primitives? For example, in Java, we know these primitive patterns, if you start int I is equals to 10, and then if I is instance of short s, 10 can fit in this short s. So this is allowed. But if we do this ordinary assignment, int I is equals to 10, Java will force us also to cast. So how come I haven't seen this anywhere else being talked about? So I asked, is there something or some exception rule happening in the Java language. They said they actually know there's an issue. So they will try to fix it, actually. So soon, this casting thing will be a compiler feature. And if the compiler can prove it, then those casting, if it can be proven by the compiler, it will always be this way. The casting is unnecessary. The reason why they want to do this is because if you program a library, if you cast every time, you only know the mistake during runtime. What if someone else add another permit here? Permitted a permit here, like the way I did. If I added this one, let's remove this. So this one is okay. So if someone added this full imply, it will be a compile time error instead of a runtime error. That's the beauty. And actually, C# and then they introduced unions because they'll provide better compile time error, which are better than runtime error. So yeah, null restricted types, etc. They do that. Even the method handles, it's the same thing. And even my typed memory, you'll see later, I'm trying to actually anticipate this kind of programming model. So yeah, I think now you understand some of those null, yeah. 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 So another thing here, I wanted to show you about how Java, the JIT optimizes your code. So actually, the JVM loves static final fields. So instance fields that can be null, the JVM doesn't optimize them. But once it sees this, oh my goodness, it becomes excited. I'll show you why. So this is a method. It looks normal. This is a sequence of execution of code. I'll tell you why it's important for native access. So static final int a is equals to 8. This is a constant, actually. And then this is static int add 1, int x. So it says x plus 1. So this variable etc. So if I call static int compute, and then I say take a, which is 8, and then add 1 to produce 9. The JVM will say, wait a minute, hey, hapa kuna some optimization we can do. So what can we do in this optimization? So this is the source level. So compute calls add 1 a, and then a is a static final. Then JTC is a. A is a constant. So it will see a is equals to 8, and then there's add 1, x is equals to x plus 1. So in the compute, it will remove add 1 method, and then say 8 plus 1. This is how it changes your bytecode when running. And then later on, it discovers, wait a minute, this 8 plus 1, it's a constant. So your method is basically static return 9. So all this has been compressed to static int compute return 9. So this is what we call constant folding. And remember what we were talking about immutable maps in the WhatsApp group. This is why we love static int, and it will generate very optimized assembly code. Imagine all those methods. It's only one line of assembly code. Yeah, so so that's why static int, static final fields are very important. So now you understand. And if you do that with method handles, it's the same thing, actually. This one, if you write method add 1, it will generate same assembly code. Yeah. That's why, if you notice, most Panama source codes. Let me go to where's the project? I hope I did not delete it. Oh dear. Oh yeah, here it is. Okay. Let me see whether there's a test example. Nope, that's not one. Let me first find it properly. A good example I've used. FM binding. No. Tests, complex dummy structure. Oh yeah. If you look at this one, is a very good example. If you look everything when I'm accessing native memory, okay, I'll explain in short. You see, the memory layout is static final. All the var handles are static final. Are all static final field, var handle, everything here except the memory itself. Because I know the JVM will optimize everything. Even the jumping strides over in the memory layout, it's everything here is final. Because that's the optimization I want to take. So now you understand how a simple concept on how the JVM does now whatever. So with that, even if you go and read Panama, based on what I've shown, you'll actually understand everything. It will be easy to read the Panama documentation and even do your first language, and I'll go through it quickly. I don't even need to stay for long. For example, of course, we need to understand what's memory. So there's memory layout, and then this is the memory representation, memory segment. This is where your bytes are stored. How to access that native memory, use var handle, and then Arena. Arena is a way of creating the memory segments. Yeah, actually, Nime explained too. Even I don't need to go in detail what they are, but now you understand the concepts in a way. So the memory layout, you define how to do memory layout. Actually, it's a very simple API, by the way. It's not complex. If you go to, where's the, let me go to memory layout. To load quickly. So you see what I was teaching you now, structure is 1 byte and then int value. But since it's 1 byte and then int value is 4 bytes, it will add some padding. And this is how you do it. Very simple. So forget the sequence. Actually, you can derive the array directly. So it has a sequence layout. So the sequence layout is memory layout, the sequence layout 5, size 5. And then this is a structure definition. You can even give it schema data, which is the variable names now. So Java byte is, now you see the importance of knowing the native type, how many bytes it is in size in memory. So if it's cha is 1 byte in Java, it's 2 bytes. So you cannot say Java cha. So you say Java byte. So kind, and then you add padding 3. The problem now, you have to do the mental calculation. So where padding should be, and if you do it wrongly, there will be a runtime error. If you say 2 or 3 or remove it, there will be an error saying misalignment or something. Very easy to understand. So, and then what it does, it describes the structure of the native memory. Model struct etc is a schema. It acts as a schema of memory allocation and used by FFM to safely access native memory. So like this one, the same struct we started before. It's chassis, and then you say value layer Java, the name C, etc, and then etc. By the way, you can say S1.size, and then it will tell you how many bytes. So memory layout is the Java description of a native structure layout. That's why I said everything has a description in Java, even the class itself in a separate model. Yeah. So memory layout does that. So you have to define the memory layout. So how do you now allocate memory? So there's a class called Arena. Okay, there's a reason I'm laughing. Okay, so the Arena has different ways of initializing it. So there's of confined. So confined means it's single thread ownership. Any memory created under Arena through confined, only one thread can own that memory. And then fastest and safest option, most common choice. That's why even if you look at my repository, I think we are done with this. If you go to my repository, everything here starts with an Arena. So I usually use type Arena because it will be, if you do it in try, it will be closed automatically. And every memory created under it will be closed automatically. So there's Arena of confined is the fastest way. Shared means accessible from multiple threads. This is important when you are dealing with files. When you are reading files, you can by the access files directly with a memory segment. Even look at the 1 billion row challenge. You'll see they started with memory segment etc. And then there's the auto. Also, the memory native memory can be garbage collected if you want. Yeah, if you don't, you say, I don't want to close it explicitly. I leave it to the GC. GC will deal with it, but rarely used. And then memory global leaves the lifetime of the application. It's never released. For example, static final fields, want to lookup table, even a shader binary to run your application. Anything that you think about where data will stay the same throughout the history of your running of your application. So this is a summary of the arena, and then memory segment. So this is where now you create the memory itself. So it has a very detailed API description. So memory segment. Yes.
Yeah, so the class arena, it's your implementation of the arena technique that's used in C and C++. Or is that provided?
Yes. Okay. Yes. Actually, thank you. You have actually stated exactly. It's the same thing. That's why the reason why I was laughing. Where is it? So, by the way, this is the guy, Tajir Valiv. I don't know whether you know him. If you ever coded IntelliJ Java, he's the one who implements the feature. Yeah. Yes. So this guy was arguing with him about why the garbage collector in Java in Russian was is a very efficient etc. But this guy is like a troll in Twitter, but an expert programmer. But I don't think he understands Java. So he was saying this is absolute nonsense. In Java, every object of yours is boxed, and your minor heap will constantly be referencing random addresses that pointer in direction I was saying, which is the worst solution. Read up on what arena allocators are to understand how cache optimized memory allocation works. So I showed him Java also has it. So I showed him the link, but he never commented. But Tajir liked the comment. Hey, but wamejibizana. So he doesn't understand Java also has arena allocators. They're everywhere. Actually, in Zig, the arena allocators. In C++, and Rust doesn't have. I don't know whether it has or not. Yeah, and many other system languages. So this is a poor man's way of implementing a garbage collector, actually. There was a time Brian said, this is a poor man's way of a GC, because once it finishes, every memory that was allocated through arena allocator is removed. It's closed automatically. Yeah, that's the purpose, and you're right. So the memory segment API, I think I opened it somewhere. So is there a simple way? Well, let me go then to my code where I started it. So here, this is an example. Oh dear, I did not give. Oh yeah, it's okay. Oh yeah, don't mind. So the memory segment, how do we create it? So there's a private instant. Memory is dynamic, so I tend to make it an instance. A field instance, but making it final, it can be a bit optimized in Java. And then there's the arena confined. So every memory segment I create inside here, it will be under this arena. So arena allocate, give it the layout, this layout, which I said, and then the size. So this is like size 10. So if this layout, I don't know what's layout byte size. Oh yeah, if we run this, I don't know. Oh, my Byte Explorer had an error. So this one will show you about the if you run the byte size of this, to show you the single struct, how the byte size is, and then it will construct those blah 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 etc. So and then now you have the memory segment, and now how do you write data inside it? So that is interesting. So you use var handle. As I said, var handles, you can access fields of class or a field of a struct. So you create a path towards that field. So there's this handle, the var handle pointing to this memory. So we start with the layout, var handle, and then path element. Now you provide the path to this variable. So the path element, since it's inside a struct, it's a group element. So it's X. You have to give it a name because it will look for this name. That's why we started with the name. we append with the name etc. And then if I want to access variable I, you say path element, group element, sequence element, and then group element I, J, etc. So you create many var handles so that you can access that data directly. So you can say get or set inside here. So I don't know whether I said get or set somewhere. Nope. Oh yeah, it's inside here. So for example, where's the get? Oh yeah, get, it has to be somewhere here. Did I put get in? Oh, I did not put it. Oh yeah, here it is. Oh, sorry. So inside the array, it's a complex way of accessing, because this is an array. This is how it is in essence. So it's a point, byte X, and then pixel array size 3, int Z, etc. So it's a bit complex when you are writing, accessing the var handles, the fields inside the memory segment. So you have to think about the loops, etc, that way. But the beauty about this, you just do get segment and then which memory allocation, get segment which memory allocation, and that's the beauty about it actually. And the same thing with set. It has both set and get. And they use the polymorphic signature I showed you. So there's no issue of casting. There's no memory performance mitigation because of casting, etc. So sorry, I showed you a very complex. When I was when I was creating typed memory, I was using this as a reference to know how I'm going to generate the bytecode for this during runtime. Yeah, so that's the essence. So memory segment is how the memory layout is. So yeah, even I had shown you, I had indicated some bytecode. Oh yeah, so it's easy. Memory segment, allocate based on this layout. And then segment, since it's a byte, the first one is a byte field. It says index 0 and then byte A, because it will cast automatically to a byte that way. But in the bytecode, there's no casting apparently. Yeah, because they are polymorphic signatures, set and get. So it's very fast. And you can create a lot of huge data, even 1 GB, even petabyte of data, terabyte of data if you want. So var handles is to assess the regions of the memory depending on those fields. So the problem is you can't say index 0, index 1. I don't know why they did not provide it. You have to explicitly know this is 0, and then it will be padded. So index 4, 8, that way. Yeah. So in the array, if it's inside an array, you add the index of the array here. So yeah, that's the idea. So for a complex var handle, instead of doing it directly like here, you can create var handle instead. Var handle, the beauty about it, you avoid now stating the complex byte offsets like 0, 4, 8. You can now do it directly without putting it, because now you show it the direct memory allocation directly. You can now say set segment and then give it an A character that way. And that's how you do memory access, native access to you can access native memory from the Java language. Now you have an idea actually. And then this is a complex approach. All this, it will confuse you. By the reason why I developed typed memory, there was a time I did a mistake. I made a mistake coding here. And then I chased a bug for 3 months. Upon the nilikasirika. By the way, I almost gave up with programming because of such kind of bugs. Because it's very complex, developing, assessing native memory explicitly in Java. So, okay, so this one is just an example of a simple C-struct, and it's a bit complex, but at least you understand the rules. You need the memory layout, and you need the var handle, and then now you can create the memory segment, which is the memory representation. Now you can add data and read data from it. So, similar thing with native functions. So 4 main classes, the linker, symbol lookup. This now looks familiar. Function descriptor, method handles. Don't need to explain much. So the linker, you access native linker. For example, if I had time, I could have programmed this, but let me go through it quickly. So there's the linker, native linker is available in the Java lang package, so you don't need to import it explicitly. You do a lookup, and then the default lookup will load the default C standard library in your computer. So for Java, for Windows, we have allow. We have the MSVC library. By the way, even if you search it in your computer, I think this is the one. MSVCP. This is available in your computer. Oh no. MSP 140. Oh yeah, it's inside my computer. So this one never delete it. It may shut down your computer, I think so. But this is a standard C library in your computer. Different operating systems have different standards of library default C libraries. So Microsoft provides theirs. So let's enter alphabet function reference. Yeah. So if you look here, there is a method called Yes. Sorry. So this is a function pointer because in native C or C++, functions are pointers. So you use memory segment to look. You say standard library. Please find this method called string length. I think if we search in the memory in the Microsoft API, if I say, and then I go there, let me go there. Yeah, this is the method. And if I go there, here it is. Yeah, here it is. So there's this string length. It accepts a string. A string is an array of char, which is 1 byte. So here you have to give a function description. So the return type is size t, which is a long. So you have to say Java long. And since a pointer is an address, you say it's an address. And then when you call it, you invoke and then create a memory segment, which is a pointer pointing to this hello. So Arena, you can allocate a string directly. So this hello is converted to a memory segment, and then you pass it to this handle, the method handle, string handle, and then invoke exact with the string inside. So it's just calling this method automatically. It's very simple. And then you can do that. So I think that's much of my presentation. Can I explain my typed memory if you guys have time? I don't know kama watu wametoroka. Oh, okay, sir. So you notice how complex it is to access memory. So by the way, I've been arguing with many people like C# provides it's very straightforward because C# has structs. So invoking a method is straightforward. Accessing memory is straightforward. But sometimes there might be some error in your application and you don't know why. So C# doesn't give you that privilege. But if you make your Java decided to make Panama everything to be super explicit so that you can add, it actually allows library developers like us to add now abstraction on top. That's why people wonder why Java is making things difficult. It's to tell the library developers, develop your own libraries and add abstraction on top, so that it's so that if we decided to add abstraction on top ourselves, you start complaining, oh, it did not do the right way, oh, it did not do the right way. So they decided to avail explicit API to everyone in various situations so that people can do whatever they want. They are also doing theirs, but they also want to give you flexibility to do that. That's why in the next 10 years, I believe Java will be the standard. Okay, I think that's far-fetched, but I believe it might be the go-to language for developing standard libraries. That's what I believe, because that's what they are doing. But people haven't noticed yet much. But the curious people have not started noticing. Hey, these people are giving us tools to do amazing things with our library. So, so typed memory. So it's all about types. For example, struct is a product type, so it's a char times int times char. One day I'll do a proper presentation on what are product types, sum types, and those type system things. But if you look here, we have been dealing with S1, so char C, int I, char D, st. I discovered since classes fields are not orderly, they don't they're not sequential the way we write them on runtime. They can be different sequences. Records provide that state description where order is preserved. So that's why records S1 can be written in Java. This strat can be written as char C, int I, int char D. So records provide state description. It's like a schema. So in future now we'll be programming. In future they are planning to introduce carrier classes. If you combine with value classes, they will separate representation memory layout with state description. So by the way, if you go to JEP for records, or let me go to carrier classes, Java, sorry. If you look at here, if you look this concept that was written in January 2026, if you say state description is how you define schema in your data type, in your type. So records, you're able to do that. And then if you say state representation, oh, it's not here, then it's in value classes. Okay, value classes. But I think it's stated in these carrier classes. I don't know why. Is there? Oh yeah, this JEP. I hope. Oh yeah, okay. It's just a word. Maybe I was being too. State representation. Actually, it's in these carrier classes. So state representation. Let me show you why. People tend to ask, what's the difference between a value record and a normal record? Why wouldn't they have developed value classes instead and do away with records? So records, you can state the state representation this way. You can define the fields this way. But here is the most interesting part. I think they gave a very good example of color class. Wachana na huko, is it? I hope hawaku delete. Aki delete. Okay. They deleted. Okay. So wacha niende kwa ingine. I think hii iko nayo. Control find color RG. Oh, color. Oh yeah. I think they modified. Okay. Maybe I can write it. So for example, these carrier classes, they're like records. Carrier class, let's say color. So you can say int R. Oh, no. Byte R. Byte G. Byte B. So these are similar to records, but now you define states. And the records will create fields. Byte R. Byte G. Byte B. Or let's say, sorry, int. Oh, sorry, let's say int. R int. This one is a better explanation so that you understand the concept. So in records, it will create these fields automatically in the bytecode. So if you look at this is 4 bytes. 4 bytes. 4 bytes, that's 12 bytes, which is bad. But in color representation, when you are doing int R, it's usually in a range of 0 to 255, meaning they can be stored in a single integer, int. Actually, it's int. So carrier classes in future, they will, if they become value classes, it will be possible to separate state description and state representation. So a representation, just think as memory alignment. So this one, I can replace it int value. And there's no language has done this. No language has done this. C++, okay, no language has done this as first class feature. It's Java wants to separate that. So with that, we can define int r, and then we can find, we can say how this state state description can be put. It can the data inside can be placed into this state representation. That's what they are trying to aim for. So, and then now this color will be participating destructuring. So you can say var r, var g, var b is equals to get. So in future we'll be doing this, or use them in pattern matching, etc. That's what they're trying to aim. So that's separating state representation and state description. So with that, once I discovered this is the direction they have, they want to take, I said, then we should start with records, because now you can define structs properly in Java. So with that, I developed a way now so that when you call this method, I created an API. When you say mem off, you pass the S1 as a class, and then the arena, and then inside it will generate bytecode so that it will first calculate the size of the memory layout, because these are sequential, so it's easy to know, and then it will add the padding automatically. And from there, it will create a memory segment, etc. And all this code will be generated automatically during runtime. And then when you say set or get, this is there will be no reflection anywhere, and your code becomes performative. I'll show you the source code. Actually, it's very interesting. So it will derive the memory layout automatically. So there's no manual memory layout creation, no var handled manual declaration, no offset calculation. All this is removed. Support flattened arrays, etc. And uses generated assessors for high performance. So this will become like normal method call. So how do I do it? So this is equals to all this. So your hardware ya ku access native memory, it's removed. Kabisa. So why typed memory uses it? So So what is the secret? So the idea is to generate the bytecode for this. And what I use is the class file API. So the class file API, I'll show you the source code. It generates optimized assessors directly as bytecode, eliminates reflection, creates schema-specific readers and writers, because if you look at the type memory, it has set and get only. So, and then enables generation of hidden classes, I will explain, and then reduced method handle, dispatch overhead, etc., and provide a alternative to the ESM and unsafe bytecode generation. Class file API, I don't need that. This means this is abstract syntax model of bytecode. It's a way of generating bytecode, but before class file API, they used to use dependencies from famous libraries. I've forgotten. There's a library called ACM something. I've forgotten. But even Java used to use it. But they discovered if they introduce new Java version, they have to wait for those libraries to upgrade. So they decided, we need to create our own API that can generate code or even modify the Java bytecode. And that's where I took my 6 months developing my typed memory. It was a headache. So if you look at my, let me go to this project. So it's down here. Yeah, it's down here. Okay, let me put it here, and then let me close all this. Control save, and then close all. And then let's go here. So the API starts here. mem. And if you go to off, let me go to where is that off? Oh yeah, here it is. So there's mem off, and then here now it is. Now this is where, no. Where is it? This is where everything starts. So in the new, this is a new version. There are some codes I did some upgrades. Let me zoom in. So so there's this objects. First of all, I have to do null checks, and then do some cache. So this is this record. Actually, it should be extends. If I write extends record, it's okay. Oh, it's supposed to be. Oh yeah, it's supposed to be extend record, I think. Yeah. Oh, sorry. Yeah. It's supposed. Don't know why it's bringing an error, but it's supposed to be extend record. But I'm trying to introduce unions. That's why I removed that. etc. But if you look at the different formats, I think here. Oh yeah, it analyzes the class, and then it will look at the state description of that class. So if it's a record, it will do some analysis. So let's go in inside here, and then there's get. So here, let me zoom in also here. So it will first check whether this type is a record, and then it will now analyze through the mem layout how that record is structured. So from there, it's a very complex investigation about the offsets, the field types. Let me zoom in. The field types, etc. Even it checks whether this field is an array. Is that array a primitive, etc. So it's a very complex. So here it's like a very complex data validation tool. And from there, you can also investigate how this memory is displayed. For example, let's do a simple test. I think I can overwrite here. I don't know whether it will bring problems. Let's create a new class and then say tests. And then say the void main. And then we do, let's say, a record, public. A record, let's say point int byte char c int I char d. Let me zoom in. I believe people will complain. And then if we come here and then say mem layout. So this is my library calling is so I do mem layout of this class point class. And let me close this program to interfere. Okay, so there it is. And then we say mem layout string s is equals to sorry, let me import it first. Oh, I have to. No. It's supposed to be one. Mem layout string of this mem layout m. And then now I do IO string. IO print. I think ln is better. Yes. So with these simple three methods, you can investigate. Actually, this should be public. Okay, so if I run this, it will print automatically the memory layout string, and then it will tell you the first value layout is C, memory layout padding. It will show you the padding itself. So it does that automatically. Actually, initially, this is how I was coding. And then I was pasting this directly to my source code when it generates this memory layout. So it does the padding automatically. And then from that, once it does, and then now I start now generating the bytecode. So the bytecode starts here. This is the generator. It's a complex thing. Aki hapa nilipata depressions bana. It was difficult. So the idea is how to generate the bytecode. So this is a generator. I start with the class file.off, and then since it extends the interface mem, so you do it explicitly bytecode generation without the compiler, because I know the rules that I need to create static final layout, static layout, static var handles, all those. It will generate all those bytecodes in detail, every step. And the beauty is that I will cache it somewhere. This type metadata, yeah. So when I call that memory segment, memory layout, if I call this many times, sorry, where is it? The sample code. If I call this many times, it won't repeat that process because I've saved the bytecode somewhere in this static, in this class value. There's a way in a memory map, in a map actually. So it checks whether that class is the same, is already has generated bytecode. Let's reuse that bytecode to now instantiate the implementation class for mem. So with that, in the JVM, it's normal bytecode, and now it behaves like normal a normal bytecode. It's like it generates this automatically, and during instancing, it's a class already, so it instances automatically. And there's no. Oh, sorry. Yeah, continue. Oh, Sasa. Okay. There's a long explanation. So apparently, if you look here, there's typed metadata cache, and then there's a very interesting class here called class value. But if you go to my typed memory, the one it's on GitHub, did I remove it already? Yeah. Okay. If you go to, here, and then go to source, and then if you notice this package, there's no typed metadata cache. Yeah, there's none. But if you go to, I think, is it mem? Where is it? I think kidogo tu. Kidogo, sorry. Oh, linitoa kabisa. Oh yeah, sorry, niko nasahau pale iko. Yeah, so there's this helper class layout layer. So this one will calculate everything, but I will use a map to store. Kweli inanirudisha tu. What's happening? Okay, it's hiding. Okay, layout rules. Where's that? Where is it? It's supposed to be here. Oh yeah, it's mekumbuka kule nilificha iko huku chini. So if you notice, no wonder. If you notice here, this is where I store the cache key. Okay, the cache key has information about where is it? Cache key is up here. It's supposed to be here somewhere. Oh yeah, kumbe it's a record, sorry. It's a single line. So the cache key has the record class type here. So I will store all the bytecode as a method handle. By the method handle can reference bytecode. There's a way you can do it. It will store the bytecode here in the method handle. You see the beauty of method handles. And then later on, I discovered that sometimes if you define records in a method, inside a method, for example, it's possible to create a record inside a method. For example, this record, let me remove this. You can declare it here inside. I discovered if you do this, and then you exit that method, you'll never access this record again. So I discovered it will forever stay in this map. That was the issue. Ikanipatia stress until I discovered I wasn't alone and the Java people knew about it. And then they developed a map class for classes. It's called class value. So this is whereby you use a class to become the key, and then it will always, you can add information to it. For example, if you look at the source code generator here, there's a class value. Where did where am I saving it? Oh yeah, here. Where's that? Oh yeah, the cache actually, cache, okay. Yeah, so this is where I changed the type to, the map to class value. After discovering, you can store information of the class and use the class as a key. The reason is sometimes when you do hot reloads or you're in a server, you shift to another framework, but still you stay inside the same program. Sometimes the JVM might remove the class completely, or inside an instant method, inside a method, the declared record might be removed completely from the JVM. But if it discovers it's being referenced somewhere, it might not remove it. And if you have like 1,000 records for it means you hog memory. So I discovered they developed a class value which removes the class if it's no longer in use. So this one is recognized by the JVM and it will remove all the information there. So I use it as a map. Yeah, it's so hidden. I was surprised and no one talked about it. I don't know, I was just Googling or I think it was Twitter, and then I came across it and I was like, hey, what? Hey, how come it's there? So if next time, if you use class as a key, use class value, never use a map. And it's very optimized by the JVM. So I store it there. So the idea is if you say, where do we call it? Oh, if you say get class value, it will discover, wait a minute, this class is not in the memory, so it will call this compute value, and then you already gave an implementation on what to do. So that's the idea. So it's not like a map. I hope that answers your question. Yeah, I didn't know actually. By the way, I discovered it 1 month ago, so that's why it's not in the new code in the repository. Yeah. So yeah, so that's the idea. And then sometimes I don't want to make sure the classes appear anywhere in your system. So there's something called hidden classes. I never knew about it, but later on I discovered hidden classes. They make your classes invisible, kabisa. And they're trusted by the JVM because hidden classes are invisible. Their fields, etc. They know they will never be assessed using reflection or using method handles. They will never be referenced. So the JVM will actually optimize them. So I decided to use them. I hope it's here in the generator. I hope. Potenga koi base code yangu. Okay, this is the bytecode, sorry. Yeah, so if I generate the class, let me. So it's usually bytecode. So yeah, very good. Define course. Yeah, typed metadata. Oh, sorry, it's here. So yeah. Sorry. Yeah, it's here. So how do you define hidden classes? Hidden classes are very interesting. So hidden classes, you use method handles also. So let me zoom in. So because you use the class file API to generate the class, and then it gives you the bytecode as bytes, you start with the lookup, private lookup. Of course, the lookup is very important. And then it has a method called define hidden class. And then you give it the bytes. And then it will generate the instance, the class itself as an instance. And then you can now initiate the class using find constructor. Remember, in the beginning, I showed you find virtual, find static, that way. Voila. And even if you use tools to detect how many classes are running, you'll never find it. You will never find it. And this is what lambda classes use, lambdas use in Java. You can never trace them in memory. Yeah. Okay. Someone wants to ask? They have become popular. Yes. Yeah. So uh-huh. Yes. Even lambda classes use them. Actually, they are so used in the Java, but you'll never know until you start now developing this kind of libraries, and you're like, but I will pollute my code base with a lot of classes. I have to delete them, etc. Then I discovered hidden classes. I was like, oh my goodness, okay, this is a lifesaver. It's as if they were, you see, they are putting breadcrumbs for people to use. That's the idea of Java. And C field, is it C field or? Yeah, hotspot. Java. Is it here? Is it here? No. Okay. Records are optimized in Java. I think I can locate. Yes. Thank you. I think I'll prove it to it's very well optimized in by the GIT. Or is it under the hood? Yes. No. Is it this one? No. Oh yes. Here it is. So this is the entry class for the hotspot. So it will look at specific classes and see which one it can optimize, which one it cannot. So if this holder is a null point, null, it will return fails. That's why null restricted types are very important in Java if they bring them. And then some classes, blah, blah, blah. But is hidden, it will check whether that class is hidden. Then if it's true, it will optimize it. So it's a very safe class to use. If you want what you say, that word, it's a tongue twister to me. And also records, because their fields are final, they can never be modified, even using reflection. So this hotspot will look at this instance, whether it belongs to a hidden class, a record, is it a box class? I think those are the integer class, long classes. Yeah. So it trusts the hidden classes. So that's what I use for my code. And najua mtakuwa curious mjaribu baadaye. So that's the end of my presentation. Should I show you what I'm planning next? Or I finish there? Oh, bado. Ay, kumbe mmebaki hapa, wale tulianza nao. Sawa, thank you. Okay, sawa. So the next thing, union types. Union types. It's a very simple concept, but it's the most difficult thing to implement. It's so difficult to implement that the current unions in C# hawaja implement properly. And there's a reason why. So let me tell you what unions are. I think you know what unions are. So remember the example I showed you. Sealed interface foo permits foo1, let's say foo2. So if I say foo, let me put this one. So if I say foo, it's either foo_f, it's either foo1 or where is that? I forgot. Okay. there's that I'm using. Oh, let me change to the US keyboard so that my keyboard is usually US type, so that I can use. Nice. Or foo2. I can add another one also. Foo3, and then here is comma foo3. So some types or sealed classes in Java are union types in a way. It's either this F is either foo1 or foo2 or foo3, but never a combination. And it's possible to know the total number. So there's a way the compiler will be able to optimize your bytecode and even your JVM or GIT. So in C# or C, let's say foo are you usually say union foo1. Sorry, foo1. This is a field. Foo2. Let's say foo1 field. And then F2, this one, and then. So in C, this is how we do it. So it can be an int, F1, it can be an int, but the memory allocation is not the total of this. It's only the largest field value. That's why I have this diagram here. So for example, if it was I32, I64, I'm pointing out to the types of fields this can accept. So the memory should be 8 bytes because it looks for the longest, the biggest field type. So it will be 8 bytes, 4 bytes. So it will analyze and 8 bytes. The problem with C is that during runtime, we never know whether this is F1, F2, or F3. That's why people put tags. Oh, sorry. Int tag, whereby int can be, value can be either 0, 1, or 2 so that you know the index. So that's why they say unions are tagged. Okay, the unions in Rust, Zig, they usually tagged unions. Yeah, so they usually tagged unions. It's because you can identify this. And in future, if I talk about the type system, you'll notice these are like sealed types. Exactly in Java. That's why I have this. And it currently looks like a simple concept, but in memory representation, it's usually a tag this way. Let me remove this. And a payload. So tag is usually like this inter, so it might be 4 bytes or 3 bytes, depending. And then the payload, which is, let's say, 8 bytes. So 8 plus 4, that's 12 bytes. So unfortunately, this is almost impossible to do it in garbage collecting languages. The reason why is that tag can be tag, and then this is a value. This is fine, but when it becomes a reference or a value, things become difficult to implement. The GC has to be modified 100% because it has to monitor whether this tag carries a reference or not so that it can reshuffle it in the memory. That's how the GC works. That's why in C#, they haven't implemented unions properly. Actually, the biggest complaint of unions, which is it's coming in the next release, unions will be boxed. So they will only be represented this. So when you put an int in the tagged union, it will be boxed. It will become now a class, unfortunately. It will be wrapped. And people are very pissed by that. And that's why Java is not in a hurry to implement unions until they figure out how they are going to do it. In these other languages, they don't have a GC, so it's easy to implement. That's why Rust has enums. Even Zig, I think it's enums. All those are tagged unions. Yeah. I hope now you understand. So my approach is to have sealed interface, and then I'll try to see whether how. So this will be the rule. Yeah, this will be the rule. So it's the interface value and then the variance. Okay, the fields. These fields are called variants. Actually, they are called variants. So this is how you are going to construct variants. Imenipeleka mbio. So even karibu ni cheesy. So yeah. So but. Hiyo nimeiachia hapo for now. Sina hurry, maybe next year or something. Now, there's another thing here, queries. Queries, is you know how you usually chain these things, map, filter, count, like Java streams. So apparently, they're quite inefficient in Java, unfortunately. This one can be a simple loop, single loop, but this approach, I think it's multiple loops, if I'm not wrong. So it's supposed to be a single loop. And then this is like you're coding this way. So there's something called code reflection. Interfikiria many years later, but I have an idea. I'll use this new concept called code reflections. I hope umesikia hii kitu. Code reflection Java. It's a very interesting concept. Actually, this is how we are going to program GPUs in future with Java. So the idea is that you program simple way, the way you program in Java. But once you add a reflect here, for example, this is a lambda call. Let me zoom in. This is a lambda call. So this is an array, and this is a lambda, what you were teaching yesterday, Sam, functional interface. Actually, this is exactly a functional interface. But you'll add this annotation, reflect. And then it will provide a programmer a code model. It's like a very detailed description that is easy to read and analyze during runtime. And then from there, you can modify now the code. You can convert it to GPU code. You can convert it to SQL code, like the way C# has link, etc. That way. So if someone constructs this, I can be able to generate this code model and then now create this loop dynamically using hidden classes. That's the idea I have. Naweza gonga ukuta, so that's the idea I have. In Rust, this is done automatically. So this one is optimized completely. For example, this will launch in your bytecode via system languages called Godball. So this is here it is. It will compile and then it will generate very optimized code. That is, it is stored in CPU register instead of L1, L2, L3 cache. So that's the beauty. That's why by the Java programmers have been, the language developers have been asked how they will optimize streams. So someone, I think, I don't know who, someone said they will use this hammer. They are calling this a hammer. But this one will revolutionize Java to compete with Python. By the way, this is a gateway to fight Python, because Python is used a lot in AI. So they'll use this to transform Java code to GPU code, to deal with AI. So and then I discovered later on, if I solve the issue of unions, instead of complex memory segments, etc., calling native functions will be like simple Java methods. And then inside, I'll be generating this, so for every method. So that's the idea. So, lakini hiyo ni baadaye ni tu, hivyo tu. So that's the end of my presentation, and I hope mmebambika.
Makofi. So that was really, really good and in-depth. Thank you so much, Joe, for showing us the insights of system level, the future of system level programming, which will be Java. So Java will become the system language of the future, system programming language of the future. So
like
that, they'll be shocked. It will just one day they wake up and everybody's writing embedded systems and GPU programming with Java. So thank you for that. Yes.
Yeah, that's why when Oracle did the layoff of workers, the Java people weren't touched at all because they know these people will be very important language.
They're building the future.
Yeah, building the future. Yeah.
Awesome. So this has been awesome. Plenty of stuff to explore, and I think for me it has just shown me how wide the language is. There's a lot of APIs that you showed that I've not interacted with, and now I see there's more you can do in Java with access to such APIs. So this was very educative and informative. And yeah, maybe we'll do a follow-up after a while to see how far you've gone with the future plans, and also to
no, I'm taking a break.
You're taking a break?
I'm taking a long break. it's mentally constraining by the way. Like if I go take a shower, I get an idea.
That's the problem.
That's the problem, yes.
You might be just on a random walk and you're like, if I don't capture this idea, I'll forget it completely.
Yeah.
But it's really cool. People can find your GitHub repository. Maybe you can share the link to the GitHub repository on the chat.
Okay.
So the one that has that project.
Yeah. By the way, I've noticed. Oh, by the way, the reason why it got a lot of interest from the language developers is because they are planning also to construct theirs, and people use wrong approaches in accessing. By the biggest problem with Java, people use non-standard ways of developing libraries. So this was a clean approach of doing it, and they're also planning. By the way, this approach in future, I don't think there will be a difference between native and Java memory. If you look at code, yeah. Yeah, and even I showed you how null is represented in the bytecode and even the JVM hotspot. Yeah, so, and you notice the one I showed you, whereby once it discovers this is a null, it doesn't optimize it.
Yeah. I remember that. It was the end.
Yes. So nulls prevent optimization, and that's what they want to remove.
And I'm really glad with the way you demonstrated it. It at least gave you some confidence to also explore that side. So maybe let me open to the rest of the meeting to anybody who has a question or comment for Joe regarding this presentation. Questions and comments are welcome.
But even a stupid question is okay. I'm very open. Yeah. So I'm just okay. Yeah.
Me, I have a very silly question. Okay, I had problems with internet hapa, but when I think I will watch this again. See, you'll post it.
Yes, actually, it will be automatically posted. So I'm live.
So to post.
Sorry. I'm controlling two mics here, so sometimes I forgot which one of them.
Hello. Can you guys hear me? Sure.
Can you hear me? Kennedy, can you
hear me?
Yes. Okay. Yeah. Can you hear me?
Yes, I can hear you. It is not you, it is me. I'm the one who forgot to unmute. Oh, but I was saying...
now...
Oh, yeah, I'm saying it will be automatically uploaded after the session is done.
Very nice. So Joe, kwani what did you do Reddit ndio ukatolewa kwa nini kwa subreddit ya Java? Because that thing is inanishangaza sana.
Wacha nikushow. Hii present something. A window is the Chrome. I think this is the one I'm supposed to share. Yeah, I think mnaweza ona. So I made a post gani hii. Goja. Oh yes. Sasa mi kwangu, this was a very complex topic. They had modified, by the way, what I modify with. So it was a complex topic here. Ile niliwashow last time. And then I did a edit and then kaambia AI ini tengeneze ikuwe kizungu mzuri. So these dudes, I think they use the software to check whether it's AI or not. Yet ukiangalia huku ndani, people comment paka hata kina Brian Goetz, even this guy who invented virtual threads, usually active commenter inside here. I think even Brian commented here. And then mjinga hapa, where is that? Kweli nowadays, oh yes, the mod. Akasema, hello, you have been permanently banned from participating in our Java because your comment violates community rules. You won't be able to post or comment. This Reddit has no AI. Kabisa no AI. Hivyo ndio nilichujo. Sasa nikaanza kuzusha hapa because there's a racist guy kwa hii thread. Wacha nikushow. Huyu jamaa. This guy is racist. By the way, aliniita monkey because uta delete hiyo part. Yes, and I know this guy has been a mod before, so I suspected ni yeye. So but yeah, so by the tulibishana huko, unaona hizi 70 mpaka nikamwambia wewe ni low IQ kabisa huko ndani. By the in future actually I use this as evidence kusema a subgroup, the mods are really bad. Yeah. So but anyway, yeah. So that's the idea. But because I used AI to modify my initial post so that hapa kuna professionals, and I wanted to come out clear in a topic sikuwa naelewa vizuri, ndio nione ma discussions za watu. Yeah. But previous posts niko nazo, I just post the links, I don't say much. Even article yangu nilipost hapa. So so baadaye nikagundua this sub ya R programming is more friendly and it has very many people. I think iko na how many people? Ina receiving around 263,000 visitors a week. Sijui how many are following, but I don't know how to check. Yeah, but at least the rules are very explicit. You can post an article etc. Kuna time nilitry ku advertise my GitHub link, nikagundua kumbe it's impossible, you can't do that here. So that's why I had to write I posted it in Newshacker. So yeah, so huku ndio niliingia. So lakini hiyo Java, the mods are bad. The people inside there, so but actually there was a time waliingia kwa shida, walifukuza a guy from Oracle in the group without knowing he works in Oracle. Then the dude complained on Twitter. Ile fight ilitokea huku ndani, ilibidi arudishwe. Yeah, Reddit is toxic, to be honest. Yeah, so that's the background. Yeah. But they are very smart people huku ndani, sio uongo, lakini haka ni of late imeanza kunifurahisha. It has no mods or anything. The only way you can only be downvoted and then they blur your writing. Yeah, hivyo tu. So that's the background info. Yeah.
Hiyo ni noma. Me, I've never knew hata kunakuwa na rules. Just go there, see whatever it is, done.
Yeah. So
imenishangaza.
Yes, hizo rules ni normal and they are actively there checking. Mi tu nilishtukia you have been banned. Alafu nikaambiwa reason why. Nikasema nyinyi ni wale mlifukuza tu Oracle.
Na so make nini, see those guys are also on Twitter, so make nini comment Twitter and then they might review.
Siko famous lakini nitarudi one day najua tu. Yeah.
Okay.
Any other comment? So Paul says, and the slides, will they be available? So that's up to Joe. Joe, somebody is requesting for you the slides. But if the video is available, I don't think you'll need the slides. You can just run through the video. Joe, what do you think? Because I understand with slides, there's usually Joe might want to have some IP protection of the slides because there's some original ideas there. Joe, if you're speaking, you're on mute.
Oh, I was saying there's nothing IP there actually. So even if zile nimewashow hapo, if for me they're difficult to implement. Actually, the IP issue is making it open source. That's the issue. Yeah, so it's okay. Yeah.
Wonderful.
Because nowadays LLMs can analyze your code and replicate. Yeah.
Something. When you had a license on your code, it used to mean something. Nowadays, the LLM can go read it, and when somebody is prompting cloud code, it generates the code that you wrote.
But ilinisaidia publish Sonatype repository. I didn't know how to use it.
Okay.
And then it showed me how to do it. I was shocked. Yeah. Even register a key. Siko najua.
Oh, what is Sonatype?
The new Maven repository.
Like Maven Central.
Yes. Yeah. Maven. But nowadays it's Sonatype.
Okay.
So they handle the repository to someone else, so that they tackle their state corporations or big companies. They have 1 million uploads in a year, or see how many months.
Yeah.
It constrains the systems and requires more computers, servers. So they said if you pass a limit, they charge you.
Oh yeah, I saw that way. There are a lot of open source people are complaining that their libraries now you made the code for free, but now you have to pay to give it to people for free.
Yes, but they are targeting corporates. That's why. Yeah.
So individual people can be exempted.
Yeah, but maximum three uploads a month, unfortunately.
That means also release cycles will be limited. That means even your updates, if you're updating the library, you can only update it 3 times a month.
Yes, even size has a limit size. I think 500 MB. Yeah.
Anyway, there's GitHub sponsors. If people don't want that, they can contribute to your GitHub sponsors. You hire a private server and you ship the bills directly from your server.
Yeah. That's the idea.
Yeah, that could. Anyway, I think that's awesome. Any other questions? So the slides will be available. I'll communicate with Joe after this and see how I can share it in the WhatsApp group. So that you can have it. If you're not in the WhatsApp group, sema mapema so that you are assisted. But most of us, I'm sure.
Yeah. Sorry, I did not create a repository for experimenting this so that you access. But the slides have the code, so it's easy to replicate.
Yeah. I think the slides are very detailed. The diagrams, it's something somebody can run. Awesome. Any other question or comment? Comments also are welcome. If this was too simple and you want us to cover more complex topics, you can also let us know. Tuambie Joe aende parking kidogo tafute to a bit more complex.
In future, maybe we can do type system, but because it's a very interesting area.
Oh, okay.
Yeah, it's yeah. So actually, I was surprised today to learn that. Too. I didn't know there's usually a dichotomy. Inaitwa dichotomy. Yenye kizungu ni ngumu. Let me show you. Iko wapi hiyo? Reddit. Kwani nilifungua wapi? Let me share it properly then. Share. Share window. Chrome. Yes. So I didn't know there are two worlds of programming. Let me. Where is it? Kumbe my comment was liked. So, no, this is Scala group. So, you hear the way Scala is functional, programming language. Yeah. Yes. So they believe the compiler is the truth and nothing else is the truth. It's called the type system world. So, I think you can hear me still. Yeah. Okay. And earphones zangu zimeisha battery sijui but nimeingia computer mode. So this shows this article it's trending. So it shows the history of Valhalla etc. And then I went through the comment section. Nikaona huyu jamaa amesema still a lot of limitations. No value classes on Java are close. New value classes on Java are closer to old school in-eval classes from Scala rather than opaque types. So, let me share the whole screen instead, so that nielezee concept. Scala is very interesting. Why is that? Let me just share the whole thing. Just be patient kidogo and then I'll show you everything, what he means there. So yeah, turudi hapa. Let me close this. Yeah. So still has a lot of limitations. So the argument here is it's a very small sentence, but it's heavy loaded. So the idea is this. So let's say this is a value class. Value class point, or okay, just a normal class point int I. And then you have a class wrapper 1, and then point P that way. This is just an example class wrapper 2, and then wrapper 1 W, and then that way. So you can say var W is equals to new wrapper 2, new wrapper 1, and then new point, and then give a value. So the old Java model, the current one, this is one object, another object, then a new point. There's too much abstraction over abstraction over abstraction. So he says the new value classes are closer to any val. So any val in Scala, you could define a type, any val, and then tell it to borrow everything in point, in point something. Any, let's say, and then point to pick everything there. So that this any val is approximately equals to point. It borrows everything from point so that it's a difference. So you don't need these wrappers. Let's say, okay, these wrappers, etc., because this brings a lot of abstraction and then identity, blah, blah, blah. So later on, Scalar advanced, and then they brought a new keyword called opaque, saying, I declare this class as my class, but borrow everything from point, so that my class is similar to point, so that I don't need these wrappers. So he's saying still a lot of limitations. And kaona, hapa tunadanganywa. And he has 14 likes. Then nikasema, that comparison makes sense in the compiler world. But Valhalla primarily, it's about state representation, what we have been learning about memory optimization. And then new type, opaque type like abstraction are a separate possible future direction. Java might consider it in future actually. But Brian alisema, no, hii sitafikiria sahi, we will think about it once everything is in place. So it's not in my mind currently. And then this guy, it's as if he didn't understand me. So he said, well, from the perspective of a language user, it doesn't really matter. What is important to me is being able to use zero-cost abstraction, because now we are borrowing everything from point class to my new class. So it's zero-cost abstraction to save a bit of memory, meaning we are avoiding wrapper 1, wrapper 2. That's the whole point. And value classes does not deliver that in a lot of real-life scenarios. Hapa tumemshika. Hapo amedanganyana. Sasa mimi nikasema sawa, acha ni reiterate tena vizuri, hujanishikanisha. So nikasema, I think you may be assuming wrapper necessarily survives as a separate object at runtime. That is exactly what Valhalla is trying to avoid. So value class point EV, wrapper 1, wrapper 2. In runtime, hizi haziko, ni hii pekee. So hii yote, hii wrapper 2, even if we instantiate, bado itabaki 64-bit memory AI. Because this don't have identity, this one don't have identity, it's only state representation, int X, int Y in memory. And then once Java JVM provides this approach, now languages can now build richer type system on top of it. That's why Ujama ameko 0 points, alafu downvote, alafu mimi nikaongezea 3 because nime-explain vizuri, alafu jamaa akaongezea story zake, lakini hata wewe nitamcorrect kidogo. So ukiwa hivi utashtukia nimechujwa kwa hii group. Yeah, so from there, that's when I discovered people who deal with a lot of functional programming, they don't know what happens under the hood.
Yes.
Lakini sisi juu tuna deal with imperative languages, what happens under the hood really matters to us. So those two worlds are very separate. Yeah, that's what I've discovered.
Yeah, I mean, if you decide to do functional programming, you have to care less about abstraction. So you just introduce abstraction carelessly, because your main goal is to be able to have the monads and the other ones in your program. But yeah, and also there's the issue of hard mentality, which by the way I don't understand in terms of JVM languages, because advancements in Java actually gives the JVM languages room to introduce additional capability. So I don't know why they always want Java to be lagging behind, or even when Java advances, they're not happy, when in fact they depend on Java advancing for them to improve.
You see, you discovered that independently. Me too. Like, that's the norm.
Yeah, it's so strange. It's so strange. Like when Kotlin came out, they're like, oh, we are replacing Java. But Kotlin code is compiled down to Java first, then it compiled down to bytecode. And when they want to add features, they use Java to add those features to Kotlin. So weird.
Yeah.
Anyway, it's interesting.
But people don't know.
Yeah.
This killer guy, Brian, is also very good with type system. Very good. Actually, follow him on Blue Sky. By the upelekananga na watu huko. There's a lady who's a geek in functional programming. Anakuanga respect sana. So they usually exchange. information a lot huko. But yeah, he is very knowledgeable. That's why ukiangalia, for example, kitu kingine ilinichekesha. So kwa YouTube, I'm not sharing. Oh yeah, I'm sharing. Sorry, value. Oh, even there's a topic, no language should have field reordering. Okay, nitaangalia hiyo baadaye. Nitaiwatch baadaye. Okay. Value classes Java. Oh, unaona hizi topics mbona zinatokea. But it's similar to what we have been learning today. So, refactoring. Hapana. No. Type classes Java. I hope ni hii. Oh yes, growing the languages. And then I go to the comment section and then I order by newest. Angalia jamaa vile worried. This is a cool feature. Zara, please deliver this soon before you return. So this guy, he's praying this guy stays for long because this is also a revolutionary thing being considered in Java. And watu wa Scala wamezusha ati mbona mnataka kutukopi juu yeah. They should yeah. Oh yeah, hizo language unaweza cheka. And nothing at the moment, yeah. But please, moving forward, mwanza fikiria about memory. It's very important. So
I'm even thinking a good way to approach this would be to take like a month or a few weeks programming something low level, preferably C. I'd say C++, but C if that's your thing. Do the low level stuff, interact with unions, structs, and malloc, and the others, and then now come to what we've covered today. I think it will make more sense that way if you've not done low level programming before.
Yes. Like how to launch a simple native window.
Exactly.
It's a very good exercise actually. You should think about it.
Yeah. So when you've dealt with that, when you come back to looking at memory layout in Java, some of the APIs that you have shown us, Joe, I think the advantages will start being clear, and you'll be able to map the low-level programming stuff and what Java is trying to do with these new APIs.
Yeah.
Sijui kama watu wa KJUG wanaweza kubali, I might suggest doing a series on C that leads down to FFM. So we start with C, we cover C language features, and then we use those features in FFM, like struct and memory alignment and stuff like that.
Yeah. But the way developing C++ in Windows is bad. It's the worst experience. Because you have to download 2 GB of Visual Studio, so people use third-party compilers. A bit amusing.
I'm a Unix person, so I can't relate.
Oh yeah, well, please, you guys you're enjoying a lot. Yeah. Actually, Linux has the best tools for analyzing performance. The best, actually. I've been rethinking of going there.
I'm surprised you are still in Windows. Join us.
Yeah.
Unix systems, for us, we install the operating system and it comes with GCC, it comes with Vim, it comes with all the tools that you need and the debuggers and everything. So your job is just open the terminal, create a file, write your C program, run it. You're good to go.
Yeah, but actually I might think of doing that. Yeah. I'll see.
Okay, cool. Yeah. Last chance for questions before we close. Okay.
By the mnaweza niuliza kuna time Ian alinisumbua the whole day.
Alikuwa anauliza?
alikuwa tu nimsaidia kitu fulani kulearn at the advanced stages of programming. I thought that was good actually. Nilimpatia mabook zangu zote. So
nice.
Yeah. So msiogope ku reach out. I'm open. So
awesome. Please reach out to Joe. He'll be more than happy to help. Because when you teach, you also check your knowledge and you improve your understanding. Yeah, so reach out. We have next week. We'll still have Java for Everyone on Tuesday. I will have another episode of Java for Everyone on Thursday, and we'll have a similar session like this on Friday, Java by example. And there I'll see whether I can get another expert discussion. I'll try and reach out to somebody who is here, either Kennedy or Patrick. There's an idea for a talk that I have in mind that you guys can help with. So I'll try and reach out to one of you to want to come. It can be possible. Otherwise, I'll see you guys again on Tuesday next week, Thursday, and Friday. Have a wonderful weekend. And naona US wamesha score 2 goals. If you're curious about the game. So have a good.
It's funny.
Okay. Have a good night, guys. And happy weekend.
You too. Thank you.